Okay, this is chapter 9.4, the tangent ratio. So the essential question in this section is, how is a right triangle used to find the tangent of an acute angle? Is there a unique right triangle that must be used? Let triangle ABC be a right triangle with acute angle A. The tangent of angle A, written as tan A, is defined as follows. The tangent of A equals the length of leg opposite to A, which equals BC. All right, so let's just start with that. The length of leg opposite to angle A. So here's angle A. The side opposite we would call lowercase a or BC. The length of leg adjacent to angle A. Adjacent is the one that creates the angle, but not the hypotenuse, is AC. And that would be side B because it's across from capital B angle. So the tangent is however long the opposite is divided by however long the adjacent is. So what you will learn is how to use the tangent ratio, solve real life problems involving the tangent ratio. So let's take a look. Okay, so using the tangent ratio, a trigonometric ratio meaning a comparison of two things, is the lengths of two sides in a right triangle. All right triangles with a given acute angle are similar by the angle-angle similarity theorem. So over here, they gave us a triangle JKL and XYZ. They are similar if angle X is congruent to angle J. Because we already know L is 90 and Z is 90. So if those two angles correspond and are congruent, angle-angle theorem says they're similar. So when those two triangles are similar, you can write KL, which is this shorter leg, over the shorter leg of the other, YZ, is equal to the long leg over the long leg, rewritten as KL divided by JL equals YZ divided by XZ. So what do? KL, so it's the short leg over the long leg of one triangle is equal to the short leg over the long leg of the other triangle. So you can either go short to short, long to long, or short and long from one equals short and long of the other. Okay, so the tangent ratio is the trigonometric ratio for acute angles that involves the lengths of the legs of the right triangle. So the core concept here, tangent ratio, let triangle ABC be a right triangle. Okay. Okay, so in this example, they're giving us this angle here. So this is the acute angle we're talking about. So if we have angle A is the acute angle, then the tangent of angle A is defined as follows. Tan A is the opposite leg to angle A over the adjacent leg to angle A. So it's BC over AC. All right, so let's take a look at this tangent. Okay, example one is finding the tangent ratios. It says find the tangent of S and the tangent of R. Write each answer as a fraction and as a decimal rounded to 4 places. So I'm going to start with S. So I'm going to say the tangent of S equals, I remember it's opposite, which is TR, divided by adjacent. So this is what I call my reference angle. This side is opposite and this is adjacent and it's not the hypotenuse. So TR over ST. So TR over ST is 80 over 18, which reduces to 40 divided by 9. And if I use my calculator to figure out 40 divided by 9, I'm going to get a repeated decimal of 4.4444. Remember what it said, round to 4 decimal places. So there's tangent of S. Okay, so now let me erase all of this. And now my reference angle is R. So I'm going to say the tangent of R equals, it's the opposite, ST, divided by the adjacent and not the hypotenuse, TR. Okay, so substitute my givens. The opposite is ST, which is 18 over 80. And that's going to equal 9 over 40. And then if I take 9 and divide it by 40, I get 0.225. I'll put a 0 at the end because it said round to 4 decimal places. Okay, so it's 0.2250. Now notice something here. Just want to point one thing out to you. Right there. Okay, the tangent of one acute angle is just the reciprocal of the tangent of the other. So if you find tan S, tan R is its reciprocal. If you find tan R, tangent of S is the reciprocal. Okay, so there's finding the tangent. Okay, so now it says find the value of X and round your answer to the nearest length. We're finding the leg length. So we're given an angle measure. We are given a side length, one of the legs, and we're given the other leg. So what you should do when you're doing these problems is label your diagram. So this is what's called the reference angle. And with reference to the angle that's 32 degrees, this side over here is the opposite. And this side here is the adjacent. Okay, you should always label your diagram like that. And once we see what we're given, a value and an unknown value, what ratio can we use? And that is tangent. So we are going to say the tangent of our reference angle, 32 degrees, equals opposite over adjacent. So I'm going to write OPP over ADJ. Okay, and that is going to equal, and then we substitute in our givens. Well, the opposite to 32 is 11, and the adjacent to 32 is X. Okay, so I'm going to write tan 32 again. So I still have this equation. All right, now here's where I'm going to teach you a shortcut, and it gets a lot easier if you will do this. I'm going to do it the long way first, but I'm going to show you how to shorten this process. When you have a denominator variable and you multiply both sides to get rid of the denominator on the right, you're going to end up with X times the tangent of 32 degrees. And that's going to equal our numerator. I'm trying to solve for X. So now I have to move the tangent of X, or the tangent of 32, away from X. So I'm going to write it as tan 32. Okay, now the tangent 32s cancel, and I finally get X by itself, and I get 11 over the tangent of 32. We want to round our value to the nearest tenth, so I get my calculator. And I'm just going to clear my screen here, and that's now when I use my tangent button. So first thing I'm going to do is go to mode in my calculator. Make sure you are in degrees. Radians are different. You won't do those until algebra 2. So I'm in degrees. I hit second mode to quit. And I have X equals 11 divided by, and in parentheses, I'm going to put the tangent of 32 degrees. And I hit enter, and the length is 17.6. And I have an equal sign. I'm rounding. It's approximately 17.6. Round to the nearest tenth. My 100th position was a 0, so we truncate, we round down, and it is just 17.6. Okay, now I want to show you. Now I want to show you how to do this in a short fashion. So let me go back to this step right here, and we have X. No, we don't. Let's go to the right here, tangent of 32 degrees equals 11 over X. Okay, so I'm going to do this on purpose because I want these to be two different pieces. So whenever you have the tangent of 32 equal to some ratio where the denominator is the variable, all you simply do is Ay, ay, ay. All right, I was just trying to make these separate pieces. So here's what we do. If we have the tangent of 32 equals 11 over x, all we do is take the numerator and move it over top of the other side. And that is what we had right here. So instead of multiplying both sides by the denominator and then dividing both sides by what's not x, you simply take the numerator over the variable and move it to the other side. Just a much easier one-step process, and we get the same thing. Okay, so that's the shortcut you should use to avoid any errors. So now you should be able to do problem number 7 and 8 in the exercises. Okay, example 3 says to use a special right triangle to find the tangent of a 60-degree angle. So the first thing I'm going to do is point out to you that they said to use a special right triangle. This is chapter 9.2. We just did this. Okay, so the first thing I'm going to do is I'm going to draw a diagram. You should always draw diagrams when they aren't given. Okay, so let's just do this. And let me just rearrange it a little because that looks like, okay, so here we go. So if this is 30 degrees here, and this is 90, and this is 60 degrees. So there's a 30, 60, 90 triangle. Now, remember, in a 30, 60, 90 degrees triangle, okay, the long side here, the hypotenuse is 2x. The short side over here is x, and this is x square root 3. Okay, that was from chapter 9.2. And so across from the 30 is x, across from the 60 is x square root 3, and across from the 90 is 2x. So we have it says to find the tangent of a 60-degree angle. The 60-degree angle is right there. So I'm going to say tangent of 60 degrees equals opposite over adjacent. And let's label the diagram. Here's our reference angle. This is opposite over here. This is adjacent over here. So this is going to equal. So we're going to then have the tangent of 60 degrees equals x square root 3 divided by the adjacent x. Okay, x divided by x cancels. So the tangent of 60 degrees equals the square root of 3. Okay, if we wanted to do an approximation, we can. So let's get our calculators out, and I'm going to say the square root of 3 is 1.732, and then this 0 get round to a 1. 1.7321. 1.732. Okay, so that's how you use your special right triangles that we did in 9.2 to find the lengths of sides when you don't have any of the lengths. They told us that the angle was 60 degrees, and that was it. They didn't tell us a side that was opposite. They did not tell us a side that was adjacent. There were no angle, or there are no side lengths, but you can use your special right triangles to do those. Okay, solving real life problems. The angle that an upward line of sight makes with a horizontal line is called the angle of elevation. Okay, so the angle of elevation is right here because line of sight's horizontal, and then you look up, that's elevation. Reviewing the angle of depression, if you were sitting at the top of the tree and looking straight out and then look down, this is the angle of depression. They form alternate interior angles to two parallel lines with a transversal. So this would also be 59 degrees. Okay, just a quick review on angle of depression. And now we have angle of elevation. So with that, I can move this up here. Let's get rid of this. You are measuring the height of a spruce tree, h feet. You don't have a ladder, you don't have a tape measure, no way of getting to the top to measure this. You want to know how tall it is. You are standing 45 feet from the base of the tree. So you can measure the distance you're standing. So you are standing right here. Okay. And you are at eye level like this. So you're standing here and you look up. This is your angle of elevation. That's 59 degrees. Okay. Find the height of the tree to the nearest foot. So with respect to this angle, this is opposite and this is adjacent. Opposite over adjacent's tangent. So you would say the tangent of my angle, theta, equals opposite over adjacent. Okay, so theta is the Greek alphabet letter theta. This is the Greek letter theta. And we use that to name our reference angle. All right, so then we substitute our given. So we want to find the tangent of 59 degrees because we know it is opposite height over adjacent 45 feet. In order to solve this, we multiply both sides by 45 to get h by itself. These cancel, and we get h equals 45 times the tangent of 59 degrees. So our h is going to be approximately, get our calculator, turn it on, 45 tan 59. Enter, and it's 74.8926. Okay, so it's 74 point, and it says find the height of the tree to the nearest foot. Okay, always read the directions again and keep track of what you're doing here. So 8 is more than 5, so this is going to round us to approximately 75 feet. Okay, so the height of the tree is about 75 feet. All right, so that's how you would do a real world situation using trigonometry and the tangent ratio. Now you can do problem number 15 in your exercises. All right, so that brings us to the end of chapter 9.4. It's a short chapter lesson. So I threw in a few review questions at the end, 27 through 29. Okay, thanks for watching. Have a great day.